Hello, so let's try this problem. It states John is helping his mother rearrange the living room furniture. John pushes on the armchair with a force of 30 Newton directed at an angle of 25 degree above the horizontal line, while his mother pushes with a force of 60 Newton directed at an angle of 35 degree below the same horizontal. And what is the magnitude of the vector sum of these two forces? So whenever we do these type of problems, so we have vectors here. First force vector is this 30 Newton at an angle of 25 degree. Second force vector is 60 Newton at an angle of 35 degree. So in this question, if you imagine the forces we have here. So first force is this 30 Newton. This is force 1. This is 30 Newton and this is at an angle of 25 degree from this horizontal. So suppose this is your 25 degree. And the next force that we have is our 60 Newton. So this one is 60 Newton and it is at an angle of 35 degree below. So this is 60 Newton and at an angle of 35 degree. So now if you remember, the law of addition of vectors is, so if you have this first vector f1, this is your f2, so your resultant will be given by the closing side of this triangle by this. So this is going to be the resultant for these two forces, F1 and F2. So now for this problem, since we need to find the magnitude of the vector sum, so what we will do, we'll firstly find the total x component, the total x component, the total y component, and then from these two we will find the total force, the vector sum of these two. So for first part we'll find for the F1, for the John's force, this F1. So for this we will have, for like suppose let's we try for John's force. So for force F1 we'll have f of 1x, which is going to be f of 1 cos of theta. And when we'll plug in the values, f1 is 30 Newton and the theta in this case is 25. So we'll have 30 Newton and cos of 25 degree. When we will solve this whole thing, we will get 27.19 newtons. And the y component for John's force is going to be f of 1y, which is going to be f1 sine of theta, and that is going to be 30 Newton and sine of 25 degree. So when you will calculate this, it will come out to be 12.68. So this is 12.68 newtons. So we got the value of f of 1x. So this is f of 1x. This is f of 1y. Now we'll find the values for John's mom. So for John's mom force, let's that be f of 2. So now the x component will be f of 2x and that will be f of 2 cos of theta 2. So suppose say this as theta 2, and when we will plug in the values, it's going to be 60 newtons and cos of 35 degree. So calculate this whole equation and I got my numbers 49.15 Newton, and f of 2y will be f of 2 sine of theta 2. So it's going to be for me 16 Newton sine of 35 degree. So when you will calculate this equation, you will get 34.42 newtons. So now, we have different x components and different y components from these two forces F1 and F of 2. So this was the F of 2, F of 1. So since we need to find the total magnitude of the vector sum of these two forces, so what we will do now, we will find the total x component and the total y component. So the total x component f of x will be f of 1x plus f of 2x. So that is gonna be 20, this one plus this one, 27.19 plus 49.15. So this is here equals to, I got the value 76.34. So for me 76.34 newtons. And then the y component is going to be f of 1y plus f of 2y, and when you will plug in the values, one is this 12.68 plus 34.42. So when you will add these two numbers, it's going to be 7.10. Now we are gonna add, just okay, so this one. So now my total force F is going to be f of x plus f of y, square of this component, square of this, and under root of this. So this is the formula to find the magnitude of the total force. So this is basically the Pythagoras theorem formula, and when you will plug in your values, so it's f under root of 76.34 square plus 47.10 square and under root of this. So when I calculated my whole equation, it came out to be 89.7 Newton. So that is the total magnitude of the vector sum of these two forces F1 and F2. Now the next part is, what is the direction of the vector sum of these two forces? So the direction, for the direction, the formula is theta equals to tangent inverse of the y component to the x component, f of y over f of x. So tangent inverse, in the total force vector, the y component was 47.10 divided by 76.34, and when you will calculate this whole, you will get theta equals to 30.03 degree. So that's the direction for the vector sum of these two forces, and this is going to be approximately so plus 30 degree. above, so plus 30 above the horizontal. So this is going to be above the horizontal.